Before we get into the next part of the presentation, just wanted to see if there were any other questions about the overview of the different tools. And just as a review, we covered EMERSE, we covered Filter, and we covered Patient Explorer, and we covered cTAKES. Those are quite a few tools. There will be time at the end of the 3-hour session, and you will have opportunities after the next session to ask questions as well. But just wanted to know if there were any other questions in regards to anything else that we were discussing. Okay, well then let's get back started. So next, Shivani will be presenting a use case of our application of natural language processing, tying both in the EMERSE tool and the Patient Explorer tool with a specific emphasis on EMERSE.
Okay, so for this use case example, I'm actually resorting to using screenshots from EMERSE user interface rather than a walkthrough, because it's usually during presentations where systems don't want to cooperate and sometimes crash. But we will have a guided session that will be more interactive. So there are some main use cases for EMERSE. The first is to bring a list of de-identified patient IDs into EMERSE to pull all the clinical notes for your cohort of patients. So for example, you can build a cohort using Patient Explorer, and you can take those patient IDs into EMERSE to pull the clinical notes related to those patients. However, it is important to note that there is an intermediary step. So in EMERSE, MRN values are actually patient durable key values from the de-identified CDW. And in Patient Explorer's current version, patient IDs are alternate identifiers from the RDB flat files, which is a discrepancy. So I believe there was a question earlier about differences between when you query from Patient Explorer and then query from DID CDW. So this was one big difference that Will and I encountered. And so, yeah, so as I mentioned, that there is a mismatch of patient IDs from the DID CDW and then patient IDs from the Patient Explorer RDB flat files. Folks at Bakar are in the process of modifying patient IDs in Patient Explorer to make them more compatible with EMERSE. They're hoping to resolve this in the next version of Patient Explorer. And then once that is resolved, then the patient IDs that individuals pull from Patient Explorer will represent the patient durable keys from the DID CDW. So it's going to become a one-to-one match. And
these are the synthetic IDs, or these are the actual IDs?
Yeah, synthetic IDs.
Okay.
Yeah. So it really just becomes a matter of copying and pasting the de-identified MRNs from your Patient Explorer cohort into EMERSE, and then pulling the clinical notes. So, but in case individuals are interested to get started right away, it's just a quick email you can send to the support team, anyone at Bakar, and they can provide a crosswalk from your Patient Explorer cohort to its corresponding de-identified CDW patient identifiers. And this is something actually Will and I did for our use case example. And it was rather a quick process. However, it is important to know that if you're comfortable at SQL and you end up pulling your patient cohort from the Microsoft SQL servers in Ray, then you don't need to go through this intermediary step since you're just pulling data straight from the DID CDW. And then a second use case is that you can actually just go into EMERSE, apply some basic demographic filters in EMERSE, restrictions on age, sex, race, ethnicity, to construct your own cohort there. But I do want to say it's not as robust as creating cohorts through Patient Explorer, which allows you, as Will was saying, which allows you to actually filter on provider information, medication orders, ICD codes. And so then the last main use case is for NLP, which I'll discuss more through the next few slides. So next slide, please. So as Will mentioned, this brings us to the use case example of work we're doing that utilizes both Patient Explorer and EMERSE. So historically, electronic health records, fully struggle to capture social determinants of health due to potential challenges such as non-existent or inconsistent data capture tools across clinics. Maybe it could just be a lack of time and extra steps for a clinician for a manual input. It can also sometimes be a really slow process. So those structured data fields for screening have become more widespread, and places like UCSF are utilizing social determinants of health modules within their inpatient and outpatient care. Some of the best source of social determinants of health data can be from unstructured clinical notes, and you can capture this through natural language processing. But oftentimes, a text corpus can be really difficult to generate, and data access can be challenging, and oftentimes requires individuals to have advanced programming skills in SQL, R, or even Python. So for this section, I'll focus on how we're using EMERSE to map and identify two social determinants of health domains, which one is social connections and isolation, and then the second is stress among patients with diabetes in their unstructured data. So for our research, we're using social determinants of health ICD codes from the Compendium of Medical Terminology Codes for Social Risk Factors. And the codes actually include 20 social determinants of health domains from 6 commonly used screening tools. But for this example, we're only going to be focusing on 2 of the domains. Next slide, please. Through Patient Explorer, we were able to identify 4,274 adult patients receiving primary care for type 1 and type 2 diabetes at UCSF from January 2018 to December 2019. So the image on the right here is how you would copy and paste patient medical record numbers from the DID-CDW into EMERSE. There's also a neat feature where you can just upload a text file where each row is a unique MRN, a de-identified MRN, which is the add by bulky upload feature. And then you have the ability to save your patient list so that every time you log on to EMERSE, you don't have to go through the steps of copying and pasting the MRNs. And then you can actually even share this saved patient list with other researchers on your team, so long as they have been pre-approved and they all have access to EMERSE. To note, there is a cap on patient lists where a patient list can only hold up to 100,000 patients. And once you go ahead and you put your patient IDs into this, and there should be a pop-up indicating whether all patients have been identified and matched or whether certain patient MRNs were not identifiable. So in our example, when we went through this process, we had a few patients who were considered to be missing patients due to their MRNs just being on the sensitive patient list. So this really just means that there were a set of patients where the healthcare compliance and privacy request to withhold just, just because some patients had been marked as confidential or anonymous in clarity, and this could be for a variety of reasons. So we did actually end up seeing a drop, but it wasn't, significant enough for us to not continue the work. And so next slide, please. Yeah, so as I mentioned before, EMERSE has some basic search filters. So this is just a screenshot from the user interface showing the different types of filters you can use in EMERSE. So the encounter dates filter will only include clinical notes between the dates that you specify. And the default date range is from February 2008 to March 2022. So this actually is a really important filter to keep in mind, especially if you're working with a cohort in a pre-specified date range. So in our example, we were only interested in patients who received care from January 2018 to December 2019. So in this case, I would apply the encounter dates feature to have EMERSE only retrieve the clinical notes for patients within these encounter dates. So prior to doing this, EMERSE was giving me all the clinical notes for all the patients in my cohort from that default date of February all the way to March. And this was just not something we were interested in. And so we needed to filter that down. And then, as I mentioned before, oh, yes.
1 moment. Would you like to answer the questions in time, or for me to save them all to the end?
I can answer in time.
Okay. So one question that we had was if SDOH, if social terms of health are not consistently noted in clinical notes, and this one I think you had said it was in the structured data actually, but how do we deal with reporting biases?
Yeah. So sometimes, so actually, a part in the project that we're planning to do is assess the sensitivity and specificity of our NLP lexicons, which I'll go over in a couple later slides, to see if we're actually pulling all the patients that have truly received the gold standard ICD code of, food insecurity or financial insecurity. So I do agree with what Edwin said, is that maybe you could do some sort of matching for exposure groups, for propensity scores, maybe even sensitivity analyses to see, if your bias is towards the null or away from the null. And then also being able to then match this back to the structured data to see if there's additional discrepancies. So those are maybe some of the ways you can address it.
Another question is there one row per patient regardless of number of encounters within reporting period?
So 1 row per patient. When I'm importing my patient list into EMERSE, is that what the question is asking?
Or it's is it all encounters? Is it patient summary, or is it all encounters or individual records?
Oh, I see.
Oh, okay.
Yeah, so it is, so the way that when I put my patient IDs into EMERSE to build my cohort, it's going to give every single clinical note associated with every single encounter, which is why then I had to include the encounter date filter range, because I didn't want a patient's clinical notes from February 2002. I just wanted it from the date range that we were interested in. And then I will go over this in a couple of slides, where even though I am applying this encounter filter date range, where I only want to look at clinical notes within those encounter dates, EMERSE has this really great feature where it will still on the back end, save their historical notes as well. So you can always go back and compare if you want to. And then I think, can I export an external data set to EMERSE? So I don't know if you can export an external data set to EMERSE, but what you can do is you can export data from EMERSE into a CSV file, which I will also go over towards the end.
So I'll speak to that question. And as of present, no, you cannot import a external data file into the EMERSE system. It is specifically tied to the clinical data warehouse with the machine redacted clinical notes set by the data center. And so if you have a external data set that you would like analyzed in a similar way, then this is where you would want to look into leveraging cTAKES or cTAKES as a service.
Yeah, and then that additional question about when X records are returned by EMERSE, I actually have some screenshots of how the results are displayed in a couple of later slides, but EMERSE has a feature where it will say, out of your 4,200 patients you're searching from, 1,000 patients have the match. And then it will produce their clinical notes. And so maybe this will be answered more as I go through the slides. But just to quickly finish off on this slide. So, right. So then other filters include vital status. So this is, whether you want to look at documents pertaining to patients who are alive or deceased. And then the last one is a document source filter, where it's pretty neat, where you get to see if you want to only look at patient notes from pathology, or only patient notes from radiology, or a combination of both, or the main EHR. So there's a lot of different ways you can play around with it. Next slide, please. So in this section, we'll go over some of the basic search terms, which are words and phrases you want to specify in your searches. So there are 3 types of terms you can work with. You have your temporary terms, you have saved terms, and then you have advanced terms. So first I'll cover the temporary and saved terms, and then I'll talk about the advanced terms. So as you can see here, I added 3 terms to my temporary terms list, which are isolated, lonely, and isolation. So I am telling EMERSE to search through the clinical notes within my patient cohort and identify any clinical notes at the encounter that I had pre-specified that have any of these 3 terms. And then I also told EMERSE to color code it. So based on the words. And so when you add terms into EMERSE, they can either be single words, as I have listed here, or they can be multi-word phrases. And typically when you put in a multi-word phrase, EMERSE will put quotation marks around it, so it knows to search for the entire phrase. And so as you can see here, none of these are multi-word phrases, so no quotation marks appear around my words. And so now the reason that I'm searching for these terms is because I'm really hoping to cast a wide net and identify patients who may fall under the social connections and isolation social determinants of health domain. A neat feature about EMERSE is its ability to detect synonyms, where EMERSE provides suggestions about additional words or phrases that you might want to include in your searches based on words and phrases you have already entered. So it's a process of sort of the system learning along with what you're entering into it. With this, EMERSE will also provide spelling alternatives. And so these the system is learning on the back end from all the clinical notes, what are some general misspelling of common medical terminology of interest. And so these are features that will pop up as you're including terms in your temporary terms list. And then as you can see on the right side, EMERSE supports a concept of excluding phrases with a search. And so this is similar to an idea of ignoring certain phrases so that you can find the terms of interest in the appropriate context and remove false positives. So to note, when you're working in temporary terms, these terms will disappear once you log out of EMERSE, and it cannot be shared with other users. So you can save these terms, which are then saved between sessions, and then these terms can actually be shared with other users. And this is another neat feature of EMERSE because the sharing and
Have you thought about the phone?
the
Yeah,
sharing
right.
and reusing
昨天有人打那个 Private Wireless， 因为我在那个我的 App 上面找，他们给我打电话，我留了一个
search terms is important because it can help ensure reproducibility. Some research terms have even included, in their saved terms as a potential appendix on a publication. And so once you feel like you have a good term bundle of inclusion and exclusion lists, what you can do is you can click on Find Patients. So next slide, please. So this right here is part of the output of the Find Patients function. And this is just a screenshot. So this is like the top half, and I'll get to the bottom half a little later. So EMERSE will give you a patient count, which is the total number of patients that are meeting the search criteria. So we can see that within the 4,100 patients within the cohort, EMERSE found 1,446 patients with clinical notes containing those terms. And as a research team, we realized that this is a really high number, and it's a bit of a red flag, and it alludes to potential false positives. And it warrants further manual review of clinical notes. Next slide, please. So EMERSE will also then provide brief text summaries from the 100 top ranked documents. And this is to provide some context for what was found to help ensure that the search retrieved is truly what you're looking for. And so this is just an example of, one of the patient clinical notes from our top 100 ranked summary. And as you can see here, this patient is considered a false positive, as this clinical note truly has nothing to do whether a patient is feeling isolated. This seems to be about some sort of a PV isolation and atrial fib and things that we are not looking for. So next slide, please. And this is another example of a false positive, where this clinical note is pertaining to microorganism isolates and some sort of droplet isolation. So once again, these are things we are not interested in. So that means we need to, as researchers, we need to create more stringent term bundles. And actually, while we're sort of doing this is a process that is actually known as developing a corpus and NLP terminology, which is essentially using social determinants of health in a compendium as a knowledge base as targets for your NLP text string mappings to find string stems, roots, and syntactic similarities in clinical notes of patients with diabetes. So as you can see, it rather becomes an iterative process to generate appropriate NLP lexicons, followed by a manual review of clinical notes to then identify true positives and false positive terminology. So while the basic search terms are a great first step to identify true and false positives, and just get acquainted to clinical notes, we realized that in order to really reduce the false positives, we had to use the advanced search strategy. And next slide, please. So the advanced terms feature is actually meant to be used by those who need more flexibility and control in their searches. This feature leverages the underlying core of EMERSE, which is Apache Java CC Lucene package. So this is a really powerful open source search engine package that's commonly used in NLP, and it allows users to develop their own query syntax. So this system on the back end is essentially doing the grunt work of NLP computational algorithm work, like Will mentioned earlier, things like tokenization and parsing. And then meanwhile, as users of this application, our jobs become so much easier because for us, it's just about creating the best NLP lexicons and requires essentially no coding expertise. So it's feasible for essentially anyone to use. Although I do have to say it is important to understand all the features of the package and different ways you can search and restrict elements within the search. And so I actually provided a link which is documentation of the features. The easiest way to understand some of these features are wildcard searches and Boolean operators, because the way I thought about it is that it really mimics how we conduct literature search strings. And then a feature that I found helpful are proximity searches, and that I use quite frequently in the work. And so what a proximity search does is it looks for two words within a certain maximum distance from one another, regardless of their order. So in the next slide, please. So here is an example of NLP lexicons we developed using the advanced search features in EMERSE. So what's highlighted in red shows the usage of wildcards, Boolean operators, and proximity searches. So for example, I have social isolation wrapped in quotes, followed by a tilde and the number 10. So this is telling EMERSE that I want to identify patients that have the word social and the word isolation in their notes in any given order, and the maximum number of words they can be separated by is 10 words. So this helps remove all patient notes that are talking about microorganism isolates or droplet isolations, because we're telling EMERSE that we want the word isolation to be paired with the word social. And then similarly, we use proximity searches in the stress domain, where a patient's clinical note must have the word feeling and the word stressed, and they can be separated by 10 words. So during manual review of the clinical notes, we noticed that feeling stressed can be documented as a patient is feeling very stressed today, or a patient is stressed and has been feeling this way for months. So as you can kind of think about this, there's so many linguistic variations of how this can be documented. And so proximity searches allows us to control for this. And as you can see from the stress domain, within the clinical notes, we discovered many terms related to stress, such as stress test, stress fractures. And so we had to use the not Boolean operator to exclude these terms. So this is where advanced features becomes really helpful, because you get to use some of the core NLP algorithms to control and reduce your false positives. Next slide, please. So here's a screenshot of the brief summary text from the 100 top ranked documents using the advanced search features. And we can see from the clinical notes that the patient you know, like the patient is lonely. And then there's another one, feeling lonely, or feelings of isolation and loneliness. And these are what we consider to be true positives. Just of note, you know, given that this is an iterative process, Will, I, and the research team are still going through a manual process of further refining our NLP lexicons to, you know, still reduce the number of false positives. But from just a simple NLP lexicon like this, we went from 1,440 something patients that I mentioned earlier down to about, I think it was 200 or 400 patients. So we're going through iterative steps to weed out the false positives, and it's an ongoing process. Next slide, please. So I included this table, which I grabbed from one of the resources I have linked at a later slide. And this summary table really helped me understand the key differences between basic search term features compared to the advanced. And when we were figuring out what would be the best method for our research question and getting the outcomes that wouldn't introduce too much noise, it really came down to the last row that I have boxed in red, which is just that the advanced search feature supports are not in the basic search features. So what I had showed earlier, some of the basic bundles that I was creating with the color coding and all of that stuff, we can't use things like proximity searches, or we can't use wildcards or Boolean operators. And so while the advanced search filter is really strong, I would say that some of the drawbacks, though, is that you can't share these strings with other users within EMERSE, or actually be able to save it within sessions. So you kind of just have to do a thorough job of documentation and iterations of your NLP lexicons, and you know, share it with your research team, and then it's back and forth of revisions. And next slide. Yeah, okay, perfect. Yeah, okay, perfect. Okay, so EMERSE also lets you highlight documents and tag patients for a deeper dive into reading through the entirety of the clinical notes, rather than reading just a simple summary. Oh wait, sorry, well, I think next slide. Okay, perfect. So this is sort of the interface when you want to highlight documents, tag patients, and then you could do a deeper dive into reading through the entirety of their clinical notes rather than just a simple summary. So what I showed in earlier slides was just a simple summary of the top 100 documents that EMERSE gave as a result. But there's so much more behind the scenes that you don't get to see. So what you end up doing is you highlight the documents, you tag the patients, and then it's a manual review of going through every single clinical notes, reading it, and making sure if this is really a true positive, or if there's something in this note that's a false positive. Are we seeing patterns within the false positives and some syntactic similarities within the false positives that we can then put into our NLP lexicon to then reduce these numbers? So yeah, as I mentioned, it's really helpful when you're making iterations of your NLP lexicons and just understanding how words could be paired together and how certain words are used in the medical context, different synonyms, and it's a really useful feature. Next slide, please. So this is another neat feature for EMERSE. So you could save your patient list and you can export them as an Excel spreadsheet. So this is just a screenshot of the UI, which shows, you have, it's a password protected spreadsheet. So you need to have your own password. Then the exported data sheet will contain de-identified medical record numbers, which match your de-identified patient IDs from the CDW, current age, date of birth, other demographic features, and then any comments or tags that were added. So you can't necessarily export the clinical notes as a whole. That stays on EMERSE. But what you can export is just your basic demographics for the cohort. So, they might help for like table ones or things of that sort. Next slide, please. So here are some additional resources on gaining access, which I know will cover in the next section, and then just the usability of EMERSE. So the link that I italicized right here is actually what I found to be most helpful and most thorough for the documentation of things you could do in EMERSE. There's a couple other things that I didn't get to during this session about how you can compare your patient lists. So EMERSE is able to produce Venn diagrams for you saying 1,000 patients are in list A, 2,000 patients are in list B. These are the number of patients that are in both. But this is the number that's unique to that patient list, and then that's the number unique to the other one. So I would highly recommend when you go into EMERSE and you want to do work in it, reading that documentation and just getting an idea of what you can do and what you can't do and some of the limitations of it before you start working. And I think that is the last slide. So I am happy to open it up to any questions or discussions.
I think I'll ask a kind of a larger context question. So what was the, for this examination of social determinants of health within diabetes patients treated at UC, what was kind of the overall research question? What did you actually, with this natural language processing analysis, what were the kinds of questions you hoped to answer?
Yeah, so with this specific one, it was mostly a comparative analysis. So we have the structured data and we have the ICD codes. So we know from a structured data standpoint that X number of patients have been diagnosed with food insecurity or financial insecurity or inadequate access to healthcare. Then what we wanted to do is look through those clinical notes, which is unstructured data, and compare, are we seeing more instances within the patient notes that gives a little bit more of a story to a patient that's experiencing food insecurity, but not necessarily has been given the official ICD diagnosis. So it was just a compare. So this portion of the project was just a comparative analysis that we identified 3 patients in the structured data that had ICD codes related to financial insecurity, but then in their clinical notes, we identified 30 patients who had indications of financial insecurities. So we just wanted to see how much more does clinical notes tell us compared to the structured data.
Is an NLP approach to clinical notes more sensitive in picking up instances of things like financial or food insecurity? Okay, I get it. So,
and then also I'd add to that. So for our aims for the project were, 1, to map the social terms of health ICD codes from this another tool developed at UCSF called the Compendium for Social Risk Factors. This was produced by the Siren Research Group. And we wanted to map the social determinant ICD codes from that compendium to UCSF EHR ICD codes. So that's another informatics exercise in order to better understand the existence or lack thereof of tracking social determinants of health within clinical data. Secondarily, we wanted to examine the associations between social determinants of health and opioid pain management practices between physicians and their patients. Some of the things that we were going to look at in that examination is also examining the association between physician opioid prescribing practices and their patients' social determinants of health, and understand that by age, race, and sex. So we really wanted to understand behavior around prescribing, behavior around other various types of pain management practices, and understand how we were classifying and noting social terms of health within various types of clinical corpi and structured data. So we still have quite a bit of work to do.